Hello class. We are going to discuss about the theorem on intersecting tangent segments. In circle P, segments AB and CB are tangents to the circle and it intersect in the exterior of the circle at point B. If we are going to draw a radius from the point of tangent C, our segment AB is perpendicular to segment AP. Also, the segment CB is perpendicular to the radius segment CP. And if we are going to connect the point of intersection to the center of the circle, then we have the segment PB. So as we can see in the figure, we have formed two right triangles. And these two right triangles are congruent to each other. So triangle APB is congruent to triangle CPB. And if two triangles are congruent, then their corresponding sides are also congruent. So the side AB or the segment AB is congruent to the segment CB. And if these two segments are congruent, then their measures are equal. So therefore, AB is equal to CB. So from the figure, this segment AB and CB are congruent to each other. So it says on the theorem that if two tangent segments are drawn to a circle from an external point, then the two tangent segments are congruent. Okay, let us apply this concept on the exercises given. Okay, in number 1, the figure is a circumscribed polygon WXYZ where XY is 8, this segment XY is 8, YZ is 10, WZ is 21. And we are going to determine the value of Wx. So this is what we are going to look for, the length of Wx. So as you can see, all of these segments are tangent to the circle. So let's assign points, or let us assign letters to the points of tangencies. So let's say this is point R, this is point H, this is point S, the points of tangency S, this one is, let's say, T. Okay. So it says on the theorem that the tangent segments to a circle are equal. So if we will let this to be A, this is also A. If we are going to let this to be B, this is also B because these two are equal. Are these two equal? Yes. So if we will assign this to be C, this is also C. Are these two segments equal? Yes, because they are tangents to the circle. So if this is D, this is also D. Okay, so if we're going to look for the letters, there are A, B, C, and D. So it is observed that the sum of XY and WZ is equal to the sum of YZ and XW. So XY is A plus B. So this is A plus B. WZ is C plus D. So this is C plus D. For our YZ, this is B plus C. This is B plus C. And for XW, it's A plus D. So this is A plus D. Okay. So if we're going to write the letters in order, we can have A plus B plus C plus D. It's equal to A plus B plus C plus D. Okay, so we observe that the sum of the opposite segments are equal. Okay, so if this is 8 plus 21, then this will be 10 plus XW. So combining 8 plus 21 is 29 Therefore, this is 10 plus xw, where xw would be equal to 19. Okay, this is how long xw is. Okay, so the concept there is, okay, so based on our solution, we can conclude that the sum of the opposite sides of a circumscribed quadrilateral is equal. Okay, let's proceed to the next example. If AX is 12, BX is 5, and CZ is 7, then what is the perimeter of triangle ABC? If we say perimeter, this is the sum of all the sides. So the perimeter of triangle ABC is equal to the sum of AB, of AC, and BC. Okay, so let us first determine the length of the other segments. So if AX is 12, what other segment equals 12? Okay, XY is also 12. If XB is 5, therefore BZ is also 5. And if CZ is 7, this is also 7. Applying the concept of two tangents from an exterior point. Okay, so adding all of the side measures, our AB is 17, our AC is 19, and BC is equal to 12. So we have 17 plus 19 plus 12 is equal to 40. Okay, it should be 58. 58. Okay, 58, the unit of measure is centimeters. So this is the perimeter of the triangle. So what the concept we applied is that the two tangents from an exterior point are equal. So these are equal. These are also equal. These are also equal. Okay, I hope guys you learned from this lesson. Thank you.